Hello everyone, it's Nono here, and this is another live stream. And for those of you who are new, I'm Nono Martinez Alonso, and this is a live stream about creative coding and machine intelligence or creative machine learning. And today we're going to take a look at Whisper. This is a transcription and translation service from OpenAI that allows you to run transcription offline, so it doesn't need to be a cloud service that you're making requests to. You can run this on device. There are some examples of people who have run this on an iPhone. I found the other day a repository who of a developer who have ported it to iPhone with C++, and this presents many new opportunities because it's basically a model that you can use for your own applications and for your own workflows without having to pay for use or anything alike, right? So I'm gonna take a few minutes just to let people join and connect, and we're gonna get started really soon. So we're gonna take an overview on what Whisper is, and we're gonna try to, I'm just gonna try to go and use it and test it and use it for transcribing, and maybe because I have in mind that we could develop some workflows to transcribe some of the things that we do here on the live stream or on the podcast, on the Getting Simple podcast. So I'll hide myself for a second, and we're gonna get started really, really soon. Okay, so just a reminder, last week we did live 90. Today's is live 91, and I took a look at some of the results that I've got by training an object detector network, specifically YOLO V7, for detecting and classifying different parts of my hand drawings. So it recognizes whether a drawing is, so this is a drawing, this is an arrow, and this is text. And some of the results were really promising. So yeah, I'll invite you to go there to take a look and watch that live stream. And yeah, so what are we gonna do today? I mentioned before we're gonna take a look at Whisper, and we're gonna get started with that right now. I also have some experiments on Stable Diffusion on Apple Silicon on the M1 chip, and maybe that's something that we can take a quick look at because I have it set up, and if you're interested, write on the comments. Some other day we could go through and see how to set it up, and it's fairly quick and it works pretty well. So I think I do have okay, so let's talk here about Stability AI and Stable Diffusion. So they have Stability AI is a company whose public mission is to democratize these type of models like text to image, image to image, in painting, and some other types of models. And they have many services. So you can install the Stability SDK with a pip command, and it's fairly quick to get up and running with using your API keys, but we're not going to see this today. The other framework that I was mentioning before, that if you at top on Mac, if you install Rust with brew install Rust, then you can install a Stable Diffusion imaginary pip package. So this is a Python package that allows us to run text to image prompts with Stable Diffusion locally. So maybe we can see an example of that. And here I had an example. So this is just like some code that you will run. So you would call here on the terminal with the right Python dependencies installed, imaging, then R5 is for generating 5 images, and then between quotes the prompt, so a scenic oil painting of trees, and then dash dash style is a flag that makes the image styleable, and then upscale is flag that makes the it applies a super resolution model to the output and makes it bigger. And then you can use this command here, which is an image magic command for basically tiling an image into in here I put like a 4K image, but you could do any size and it will generate a tiled image. And yeah, for example, you can here on the bottom you can also specify the amount of steps that you want the model to apply to generate an image. The more steps, the more detail, and the longest it takes, the longer it takes. But also if you make it super high, it will start degrading the quality of the image. And this is the example of a scenic oil painting of trees. So for example, that was one of the outputs. And tiled, you can see, is this one. So we generated a 4K background image, in this case with Stable Diffusion. So yeah, let's take an actual look. So this is still Stable Diffusion because I have it installed here, and we're gonna take a really quick look. So for me, I just have to okay, let's actually do one thing. I have a folder for this live stream. We're gonna bring it here. We already have some things. I actually have been playing with clip as well, so with the clip model, and doing some other tests, and also been trying to generate images with the Stable Diffusion offline, just to make sure I understand all of these things before I talk about them here on the live stream. So the thing I have installed here is an Python environment. So I can do conda activate imagine. That's the name I put for this environment. And we're gonna do here a folder that's called live, that you see is empty, and we're gonna put it here for a second behind me. And what I'm gonna do here, I'm just gonna do here imagine, and I'm gonna put here astronaut playing Game Boy, and we're gonna make it tileable. So I just called that prompt. I'm not sure. So this is being executed on my local machine. So we have here a tile. Okay, so it's tile. Okay, so this is being executed on my local machine. So I'm not sure if while I'm live streaming, this will make my computer slower or something. So if there is some latency, that might be the reason. And the one thing is there's things running on here, and I have already run commands before. So if you run this on your machine, you're going to see that many models are going to be downloaded, and these models are big. Like some of them are 2 gigs, 4 gigs, or things like this, and there are different models that have to be downloaded for the framework, the imaginary framework, to work. So you need to be patient and have some memory on your machine to make this work. All right, so you see it created here to the left this outputs folder, which contains generated images, and it has our generated image here. No Game Boy present here, but it definitely made it tileable, right? So you can see that you get some sense that this image can be tiled. And how do we tile this? Note that the name of the file actually contains the prompt, so it's a good thing because this was a generated image, and contains the values here of, I think, PS, this is the attention that it pays to our prompt, and this is the prompt here. And I'm gonna copy the name of this image, I'm gonna go here. You can see that here on outputs generated, we have that image. So what we're gonna do, we're gonna use this command that I prepared here. So we're gonna convert, because this is a 512 by 512 image. We're gonna actually make a 1K image. So we're gonna do here, let's make this bigger, convert, our size is gonna be 1K, and we're going to tile that image. So outputs generated and the name of our image, and we're gonna put here the same name, tile. Let's see if that works. No, found. All right, so the one thing that is a bit weird is that this command, I'm inputting the path. So what we're gonna do, we're gonna actually go into generated images, and we're just gonna remove that from the tile name. No matches. Okay, let's see, tile. Yeah, actually, let's just copy. Let's just simplify the name. All right. Okay, so now that worked, and we have this tiled here. And this is the background or the image that we've just created, right? I'm not sure how you'll see it on YouTube, but I can see it's a bit pixelated because this is 1K and my screen is 4K. We could have increased the resolution by specifying the upscale flag you can see here. So let's try that out. And so we're gonna put here astronaut and astronaut tiled, and we're gonna put here. So now we're going to imagine an astronaut playing Game Boy on the beach, and we put here upscale. All right, so that means that now our image is going to go from 512 to, I think, 1048 to 1048. And this is going to take some more time, so it's going to be a bit longer. And for those of you who are connecting live, I would encourage you to say hi in the chat, to tell us where you're connecting from and how you found us or what you would like to see on this live stream. All right, so this is generating now, and okay, so this is generating now, and now it's upscaling using real ES argan. While this is generating, maybe what I can do is open here. So open the GitHub repository. So you can find that at, okay, so imaginary repository. I'm going to put it on the YouTube chat. There you go. And this is AI imagined images, Python generation of stable diffusion images. So this is a framework that allows us to generate images, and you can see that the installation process is fairly simple. Is what I mentioned before, pip install imaginary, and I recommend this inside of a custom Python environment so you can isolate it from everything else. It works on Linux and Mac OS M1, so Apple Silicon, and you have to have Rust installed. So you can do brew install Rust if you want to install Rust, and then you can run commands. You see, you can input multiple prompts. You can there is many things here that you can do, and we're not going to go through everything here because I'm going to try to look at Whisper really quickly before I go today. But I just wanted to give an intro of what we have from Stable Diffusion and what you can actually use. Yeah, hi Bea, you can see you're connecting online. Can you see me okay? Can you hear me okay? And we're gonna see Whisper in a second. So to continue with this, okay, so now we have created you can see here, okay, we're gonna put this here and this other folder in here. Remove this. And now what you can see is that we have this generated image that is 512 by 112, but this other one is upscaled, is 248 by 248, right? So if we open both images, so this is the one from before, if we open both images, you can see that this has been upscaled. Let's open them side by side. And it has a lot more detail, right? So it has a model that knows, it's a GAN that knows how to do super resolution in this image. So now we can go back to our images. So instead of generated, we're gonna go to upscaled, and then in here we have this really long name, which we're gonna again just simplify its name. And we're gonna do now convert. The size is gonna be 4K. The tile is gonna be our astronaut on the beach. And the output is gonna be the same but tiled. Okay, and there we go. And we have this tiled background of an astronaut on the beach. It looks more like he's on Mars, or she's on Mars, on Mars. But yeah, this works, and that's how you can generate images. So yeah, we'll play more with Stable Diffusion, but this is just like a framework that allows us to make it work on our computer. So one last prompt, so we can generate like 4 images of an apple on top of a MacBook laptop. And this is a flag that's going to generate 4 images. Remember, we have a live stream, I think live stream 88 or 89, in which we were using DALI's API, so we had to pay 2 cents per image. Personally, I think the quality of DALI's image API is better, so it produces better images than Imaginary, at least so far, than Stable Diffusion. But at the same time, it's free and we can play with it a lot more. So here I'm just gonna log in into OpenAI and to see the DALI prompts of my history, things that I've generated, right? And you know, the quality of some of these images is a lot better than what you can get, I think, with Imaginary. So if we get the same prompt that we have generated here with DALI and put it inside of the inside of this other generator, so we're gonna get a few images of this. Okay, so let's get 4 images from this prompt, and we can see again, so our output got here. Let's put them. Okay, all right, so let's see what we generated with the Apple prompt. So an apple on top of a MacBook. Right, so it generates images, but it doesn't look as well as I can see with images generated by OpenAI's DALI. You see, so I mean, maybe there's one thing that needs to be taken into account, and is that each model, even different versions of Stable Diffusion, will have different word modifiers that will make it work in a different way, right? And even when they updated DALI to the latest version, when they retrained or they fine-tuned, the things that you could generate with it changed a lot. So something like, so what did we put there? So something like digital art or Pixar astronaut or something, those words might perform completely differently inside of DALI compared to in what is this other model, a stable diffusions model. Okay, so let's move on. So let's wrap up with stable diffusion because we don't have too much time. Yeah, and so hi Juanda, so nice to see you. Me alegro verte por aquí. So yeah, Juanda is asking if I'm using the GPU on my machine because the image command works really fast, right? So if we go to the desktop, so let's imagine that we go to in here to a new folder. You can see there's no outputs folder there. If I activate again this imagine environment, let's make this slightly bigger. What's gonna happen is that when I run this command, so imagine R, and then we say give me 10 images, I don't know, like candy minimalism, banana, so yellow banana, white background. So when I do this, it's actually so the stable diffusion model, at least what the repository says, is running on the M1 GPU, right, on the laptop's GPU, and this makes it, it uses the computer so the GPU on my machine, but this makes it super fast compared to using a CPU, and it makes it free because we're using local compute power and local GPU power instead of having to request images to a service. So this is, for me, is really exciting because we've seen the Apple Silicon transition from the first M1s to the M1 Pro and M1 Max, and now to the M1 Ultra and M2 chips. And I'm sure that Apple is going to release new M2 Pro and Max chips really soon. And this is really promising because it means that you might not want to train or retrain models on your local machine, but you're going to get the opportunity to do things like this, like maybe make applications that run certain models that are already trained on your machine a lot faster than if you didn't have this GPU usage, without having to have an NVIDIA card on Mac, and without having to pay for a remote service or maybe go into Colab every time you want to generate an image. For me, I mean, it's super convenient. As you've seen from the command line, we're generating images. So we've asked for these images here and like them less or more, but these are all images that have been generated here, and I'm sure there are a lot more things that we can do here that I'm not um, doing, but it's a really nice experiment. Let's actually, now that we're looking at this model, let me actually take a quick look at the imaginary, because there is this option that I've seen where we can put the seed, I think. Yeah, so we can put the seed and the steps. So one thing that I was interested in is imagine, and then we say a banana, and then we put seed is gonna be 100, and then we put steps 1. So we could, I guess we could generate the same image because it's going to be the same seed multiple times with different steps, and understand what the model does when you increase the amount of steps. Okay. So just, you see, it just runs one step. right? So this is with one step. So let's maybe make this run with 10. We could do a for loop on bash, but and I'm not sure if you can parameterize this in some other way. Let's just do it manually for now. So this is now 10. I'm gonna do later maybe 25, later 40, later 50, and later 60. So supposedly, because it's the same seed, it's gonna be working on the same exact image in, and we're gonna see the image being more and more detailed. Yeah, so after 10 steps, you can see that the model has already detailed this a lot. So yeah, maybe let's see what happens if we do like maybe 3 steps and 5 steps and 8 steps. And of course, the more steps you do, the longer it's going to take to generate. But having fewer steps is good if you want to just try with a seed and see results, and then maybe later you say, okay, I like this image, so now I'm going to detail it more. And just a really quick reminder, if you're live now, make sure to subscribe and click on the bell to get notified when I go live next or when I upload new videos. And give me the thumbs up, like the video, to support the channel and the work that I'm doing here. All right, so this is 25. So you can see it's the same image, but it's actually transitioning to a different step. I wish, like, I'm not sure if we can save the image with different steps just from one generation, like saving at each step. That would be really nice. I'm like thinking now this is 50 steps, so it's gonna be taking a bit longer. So this is 40. You see what I mean? So there is some sort of animation there from the very first steps to later on. Yeah, so maybe da, da, da. So Juanda says, I understand steps are great for creating animated GIFs of how the model obtained the final result. Yes, so that is what I think we should try to do. I would say I'm not sure if I'm gonna be able to do anything with Whisper now because we got caught by playing with Stable Diffusion. But if not, we'll move it to the next live stream. And yeah, hello to everyone who's live. So if you're online, tell us where you're connecting from and how you got here. You see this, so the model, it's not that it improves or gets worse, but it just continues trying to make this look more like a banana, and it just goes wherever it thinks it needs to go. But yeah, if we, so let's actually try to do that really quickly. Okay, so we're gonna see how to animate a prompt on Stable Diffusion, right? So how to get different images generated at different steps and generate an animation. So I'm here, and how for I in sec10 do, how was this? Let me look loop on bash. Okay, for I in sequence 10 do all right, so we get the sequence. So can we do, okay. So this is to get from, okay, so we get a sequence. So we could, let me show what I'm doing here. Let me explain here. I'm trying to just make a quick look on Bash, so we don't have to program anything else. So we can do here, let's see if we can multiply. Let's see, can we, okay, so maybe we can define the steps. So we go from 1 in steps of 3. Can we do that? 1. All right. Yeah, so it seems, okay, it seems like in here we're going from 1 to 30 in steps of 3. So that, you know, if we do, maybe if we go to 15 in steps of 2, or to 16, we go from 1 to blah, 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 blah. Okay. All right, so we can do that. So what we're gonna do, if we activate Imagine here, let's see what object we can generate. So we have here some more images, so you can see, yeah, so this is 3 and 5, so it might not make too much sense to do it at the first steps, but this is 8. Not really sure. Let's try it either way. So we're here, and we can say now that what we're gonna do is we're gonna call imagine seed 100 steps I, and then our prompt is gonna be so I have some other images generated here, I think. Yeah, so let's see. Well, let's just put here a scenic landscape by Edward Hopper. And I think that's it, right? Okay, so you see here, we're gonna do a loop, so a for loop, and this generates a sequence of numbers that go from 1 to 15 in steps of 2. And for each of those numbers in the loop, we're gonna do this command, imagine seed 100 steps, this amount of steps, and scenic landscape by Edward Hopper. All right, so let's run that. Okay, so I'm back. All right, so let's see how this is going. Da, da, da. Anyway, Juanda, if you're still there, how's everything? So what have you been up to lately? I saw, you know, we saw some of the experiments that Juanda had done on, I think it was here. Did you share them here? Yeah, so here. I haven't still tried to do this on my own, but I guess like this is also training your own stable diffusion model, and this is with Pixar. Training Stallion, the Dream Booth on Stable Diffusion is able to train with. Yeah, so this is something that we want to also do on the live stream. Okay, so how are we doing here? So we go to the desktop and open here. These are the outputs that we've generated so far. Wait, where are we? Oh, okay. So I'm generating on in here. Okay, yeah. So there has to be a more efficient way to do this, to be honest. But this is how um, we're doing it right now. And of course, if we reduce the step to be every step instead of every 2 steps, it will be smoother. But I think this is pretty good. I think I can even loop through these ones like this. All right. You see, and what's interesting is that even though you get to this end image at 13 steps, you could have liked this image more, or this one, right? So yeah, it's interesting. Like seeing the process, the generation process, instead of just getting the end output, I think is good. And note that these images are taking longer and longer because they're regenerating all the steps. So we're not saving the actual path of that generation. But what's good is that because now we have that script here, we could actually say, okay, now go from 17 to 1921, for example, right? And do the same thing. So if we did this, so we can say, okay, from 17 to 21, do the same exact thing. And what the model is going to do is that it's going to just use 17, 19, and 21, and it's going to generate the remaining images. And now we're going to make a GIF. So let's actually just make a GIF in there. Outputs generated. We have these images here. So for this, I mean, GIF making with Image Magic, I've done it many times here. Really easy. We just put a delay. It's gonna be like maybe 1/5 of a second per frame, and everything in this folder is gonna go to scenic landscape.gif. We're gonna put a timestamp here. And with whatever images exist, we get to this. All right. And that's still not done, so we still have a few more images there. It seems like it goes back and forth. It's kind of like trying to move and going back and forth between some of the things that it generates. All right, we have one more. Let's regenerate our GIF. Maybe make it a bit faster. And this has finished now, so we're gonna regenerate that new GIF, and there you go. And of course, I mean, we could go to many more steps, but we don't really need to. I mean, it's up to whatever you want. All right, so maybe we can share that online. explain with, so is there imaginary? Is there like, let's see if that is actually a hashtag that people are using. Not really. Yeah. Okay, so we're gonna put this here and we're gonna share that GIF. Oh, what's nice is we could have tiled it, and then we could actually tile it and then make the images larger, and then we could make a GIF, like a landscape GIF. Right. All right, so let's share the repo. Okay. All right. Okay, so that is it for Stable Diffusion today. And I will say again, okay, let's actually do a bit of house cleaning. Open outputs, generated. I'm gonna put these ones here. All right. And there's nothing here, so we're gonna delete that. All right, so we have those, and I had more that I had generated from other streams, and as promised, what I said before, so remember, we're gonna take a look at Whisper AI. So let's let's do that now. Okay, so let's see what Whisper AI is and how we can use it to transcribe our own audio without without having to use a cloud service or like another GPU or something. So we can use this locally. So Whisper is an open source neural network that, in summary, is really good at transcribing English speech recognition, transcribing that to text, written text, as you can see in here, and also translating it to other languages. So this is a task that has been improving and improving, and it's getting close, as it says here, is close to human level understanding, right? So I have my headphones here so I can share audio with you. So we play this sound.
This is the Micro Machine Man presenting the most midget miniature motorcade of Micro Machines. Each one has dramatic details, terrific trim, precision paint jobs, plus incredible Micro Machine pocket playsets. There's a police station, fire station, restaurant, service station, and more. Perfect pocket portables to take any place. And there are many miniature playsets to play with, and each one comes with its own special edition Micro Machine vehicle and fun, fantastic features that miraculously move. Raise the boat lift at the airport marina, man the gun turret at the army base, clean your car at the car wash, raise the toll bridge. And these playsets fit together to form a Micro Machine world. Micro Machine pocket playsets, so tremendously tiny, so perfectly precise, so dazzlingly detailed, you'll want to pocket them all. Micro Machines and Micro Machine pocket playsets sold separately from Galoob. The smaller they are, the better they are.
All right. So that is a super complicated audio to transcribe, and if you had to do it manually, it would take you a long time. So what we can do is we can input 30-second chunks of audio, and then this model would transcribe them, right? And yeah, I have to say I haven't used this model too much, so I've just been looking at it and wanted to do it. and there are multiple tasks that it does. So English transcription and into English speech translation from Spanish to another language, non-English transcription, no speech, background music playing. All right. And yeah, so let's, it's also telling us here that ChatGPT has been released. I'm not going to play with it too much, but we could ask here, how can I use Whisper AI to transcribe audio in my local machine? I don't know if this is even on. It's a language. It's a large language model trained by OpenAI. It is not capable of transcribing audio as it's only a text-based conversation AI. Whisper. I think it's confusing itself with it. But yeah, so here, I mean, this is ChatGPT, so hopefully we can take a look at it soon before they put it behind a paywall. Okay, but yeah, you could ask it like, how can I, uh, what layers do I need to use to create a generative adversarial network with Keras and TensorFlow? Right, so this is nothing to do with Whisper. This is just ChatGPT, and we can copy this question and put here, what are the layers in a generative adversarial network's discriminator layer? The discriminator layer in a generative adversarial network is a deep neural network that takes in samples from the real world data and the generated samples from the generator and determines whether each sample is real or fake. The discriminator layer typically consists of several layers of convolutional, fully connected, or recurrent neurons, depending on the type of data that the GAN is trying to learn. The output of the discriminator layer is a binary value that indicates whether a given sample is real or fake. Train correctly, classify real sample images. This adversarial training process allows blah, blah, blah. All right. So yeah, so this is something that you can access at chatopenai.com/chat. So I'm going to put that here as well. And I'm going to put also the Whisper. It looks nice. Yeah, ChatGPT is super impressive. So if you have any questions that you want to do, we have the possibility of testing prompts. And then Juanda here says, just now in training another model, I'm trying to train another model with Dream Booth, but it is about 1 or 2 hours waiting for Google Colab training the model. All right, I would love to see the results. If you put them on the Discord server, that would be awesome. And yeah, so where is Malaga, Spain located? Malaga is a city located in southern Spain, in the autonomous community of Andalusia. It is the capital of the province of Malaga, and it is one of the largest cities in Andalusia. Malaga is located in the Mediterranean Sea, about 100 kilometers east of the Strait of Gibraltar. It is a popular tourist destination known for its beautiful beaches, museums, and historical landmarks. So we look for this. Do we find Wikipedia? Okay. All right. So let's actually note here that we diverged again. So this is ChatGPT, and then animating stable diffusion images. And now here, all right, so let's take a look at Whisper, right? So we've seen here speed talking, K-pop, Whisper est un système de reconnaissance automatique.
One of the most famous landmarks on the borders. It's 3 hills. And the myth is that Merlin, the magician, split one hill into 3 and left the 2 hills at the back of us, which you can see.
Okay, yeah, so this is still generating, and this generates the generator network. Okay, what's the Python code of a text to image diffusion model written in Keras? So yeah, this is actually writing the code for us. So this is still ChatGPT. Yes, it's really crazy. And what's the Python code of a text to diffusion? The exact Python code for text diffusion model will depend on the specific details of the model. However, a simple example of text to image diffusion model in Keras could look like this. So long short-term memory. Yeah, so this is using long short-term memory models, which have been sort of deprecated, I think, now in lieu of transformers. So, but yeah, I don't know. I think this is really wild. All right, how can we create a custom Conda Python environment with TensorFlow installed on it? So we create Conda create my environment, Conda active my event, Conda install TensorFlow. All right. And what if we want to do the same? How can I create a custom Conda Python environment with TensorFlow and have Python's pip package manager install TensorFlow on it? To create a custom Conda Python environment, I have pip install and use the following steps. Conda activate my environment and then type pip install TensorFlow to install TensorFlow using pip. Oh, wow. Okay. You don't need me anymore. You can just ask all your questions to OpenAI's ChatGPT and that's it. So I think this is pretty crazy. Yeah, they also don't have a way to save all of these things on your machine, but I can see people creating a lot of content on the web just with this. I mean, I could create posts on my website just with this. All right, so let's actually close this now and start with Whisper. Okay, so let's see how we can actually run Whisper. So this is a repository, so I'll put the repo on the notes here. And let's see how we can run this locally. So this is on Ubuntu, on macOS. So I do have FFmpeg already installed on my machine. And pip install to identify the latest version. Please run this. All right, so let's actually create a new conda environment for this. So we'll do conda create whisper is what I'm gonna call it, and we're gonna do Python 3.9. Oh wait, I always like to add the yes flag because that way it doesn't ask me about what it has to do. Okay, maybe just put one equal sign only. All right, and we're just gonna activate that environment when this finishes. So we'll do just conda activate whisper, and we're gonna install this code here. So this package. I'm gonna, okay, so let's wait. And pip install setup tools. You may need Rust install as well in case tokenizers does not provide a pre-built will for your platform. If you see installation errors, you can do this. So let's see. And then we have these models. Whisper language. Okay. So it seems it's just like a simple command line interface. So let's try this. So we're going to install Whisper. And while this is getting installed, what I'm going to do, I'm going to open my audio recorder session here. So we're going to open, where is it? Okay, here. And I'm going to actually record to, yeah, so we're going to record here. So let's actually do one test. Hi everyone, this is livestream 91 and we are streaming from Malaga, Spain. We can get up to 30 seconds per chunk of transcribed audio. I guess the command line tool of Whisper might allow us for automatic handling of longer files, but just for testing purposes, I'm going to keep it below 30 seconds. All right, so now I have my audio recording here so that we can listen to. Right, so we're gonna put this here and we're gonna put this inside of Whisper. And let's see if this has installed. Okay. New connection, failed to establish a new connection, node name or a server node, a simple numpy. It's still running. Okay, so it's retrying. I'm not sure what's going on, but it's failing to install. Okay, let's actually just, oh, okay. So we need to allow that connection. My bad, I didn't see that. All right, so we're gonna go to here, conda activate whisper, and we're going to run that command again to install this with pip. And now the Python installation should have access to, yep, to the internet. So that's installing now. And I guess what we need to do is just wait for this to be installed, and we're gonna do some transcription tests. All right, so I'm gonna wait for this and I'll be back in a second. While I'm out, oh, okay, so this is working now. So give me one sec, let's see. All right, so can we simply whisper? We can use it also in Python, which is really nice. Okay, so whisper language, let's just specify here language English. I don't think we need to do that, but yeah, let's just do this. 1, 2, 3, 4, 5, 6. Okay, moving 16 files to the new cache system. So is this, what is it doing? So this seems like what happens also with Stable Diffusion, that you download the framework, but it's not until you actually use it that it downloads locally some files that are, this is probably downloading the model. And if we go to the repository, we can see that there is file here. You know, these base models are, yeah, I don't know about the size. All right, detected language English. FP16 is not supported on CPU using FP32. All right. Hi everyone, this is livestream 91 and we are streaming from Malaga, Spain. We can get up to 30 seconds per chunk of transcribed audio. I guess the command line tool of Whisper might allow us for automatic handling of longer files, but just for testing purposes, I'm gonna keep it below 30 seconds. All right, this is pretty good. All right, let's do it. Let's do it one more time. So let's try here. Yeah, bye, Juanda. Have fun. All right, and I'm just recording another test audio. We're gonna go now. So this is a really quick test of Whisper AI. We've also seen Stable Diffusion working, and we're gonna keep using Whisper and implementing it on our code. Here, we just, as you saw, we just created Conda environment, and we're recording some audio voice notes, and I'm gonna let it go above 30 seconds. And what we've done is that we just called a command that says whisper and then the audio file path. So seems fairly simple, right? All right, so we're gonna reveal this file. We're gonna move this to this other folder, and we're gonna input whisper, and we're gonna put the new one. And all right, so something I didn't realize before. So this actually is creating subtitle files and a text file for the audio that I've transcribed. So it detects that language is English, and now it gives us on the command line, it gives us the transcribed text in there. All right. All right, I'm just, okay, so let's actually listen to the note with the text and we can wrap it up. All right, so now it's saved everything. We're gonna open it in here and we'll reproduce the voice note. All right, and I'm just recording another test audio. We're gonna go now. So this is a really quick test of Whisper AI. We've also seen Stable Diffusion working, and we're gonna keep using Whisper and implementing it on our code. Here, we just, as you saw, we just created Conda environment, and we're recording some audio voice notes, and I'm gonna let it go above 30 seconds. And what we've done is that we just called a command that says whisper and then the audio file path. So seems fairly simple, right? I think this works pretty well. And yeah, so we're gonna call it a day. We're gonna keep working more and using Whisper more. This is fairly simple, I have to say. And this is surprising that it works so well and that it's a model that we can just use on our computer for free. I have a pet project I want to do, which, you know, I create, as you might have seen if you've been watching the live stream, I create these markers as we I create these markers as we record the live stream. And one thing I want to do is I would love for Whisper to take maybe the next 10 seconds after I click on the marker and write the text here. So for example, if I create a marker, this gets created here, right? So it'd be good if I do the marker and then I say, and now we're going to talk about Whisper AI. And then here you would say, and now we're going to talk about Whisper AI, right? And then my markers will be really easy later for me to learn what they are, because there is some context there that we can obtain. So that's one project that I want to do, to integrate this on the stream. And yeah, so we've seen a bit of this stuff. Don't forget that you can join the community on a Discord, and none of the Master's Discord. And yeah, thanks a lot for watching. I'll see you next time. And don't forget that you can subscribe and click on the bell if you want to get notified when I go live next or when I upload new videos. And like this video to support the channel. One thing I'll show here that we've released that is new is an episode with Zach Krohn. So this is Zach, is his second time on the podcast. We talk about art, creativity, and personal evolution. Actually, we talk a lot about many other things. He's a senior product manager at Autodesk. And here are the topics. As always, you can browse them and click on them on the episode markers on YouTube. And we talk about many things. It's a long form episode. You can actually,
as long as there's,
you can actually watch it on YouTube. It's a video podcast. As I said, you have chapters here. So for example, if you want to see when we talk about function list,
I feel like I've misunderstood this concept for my own purposes.
And pen plotter art is something that you can see all this art that Zach has made on the pen plotter, right? Like with a machine similar to the AxiDraw. Awesome.
It comes down to people were. From there,
and I actually do a walkthrough of this.
I started doing a whole bunch of other drawings that were really about, they were kind of pixel art. They were, but done with,
But yeah, so that episode is there, and we have one coming out with Alex O'Connor in the next few weeks or months. That's where we talk about stable diffusion, transformers, and many of these things that have to do with AI and machine learning. All right, so that's there. I'll put the link. Zach Krohn's podcast episode is here. And yeah, thanks everyone for being there. I'll see you next time. Let's see, how do we stop this? Bye. And don't forget to write in the comments if you have any questions, any topics you'd like to see on Discord, on the video comment, or wherever you want to see it.